we'll go into the next question. Okay, let's go to the next one. So I want you guys to tell me your previous experience in a programming language. So if you have taken applied stats, then your answer is the first one, at least. um, if you probably have applied it either working or as a personal project, or you actually like to do this kind of stuff, it's probably the second one. Okay. All right. Okay. Sure. Let's go back. All right. So for those who answered that have working proficiency in one language, or those who answered that have working proficiency in more than one, which languages are those? Also, the ones that answered basic, please tell me what language is that? Python, VBA, Stata, Stata. Now, answer honestly. Do you do you guys actually like Stata? Yeah, I imagine that. So it's great that the university has given us free license on Stata, but it's so ancient, you know. Yeah, people continue to use Stata on the research world, but on the academic research world. Um, on the actual, so there are two branches on research. There's onto financial research. There's academic, in where they use primarily little bit of Stata. R has started to penetrate that world, but there's not much. Into practical research, into development in the private world, at least in finance, it's mainly Python and then R, depending on which kind of job you go to. If you're say an algo developer, you're not gonna be using R. You're probably gonna be using C++ or something like that. But since most programming languages are really similar in between them, once you learn one really good, it's really easy to catch up on another one. So let's go with R. So I'm gonna open up our studio, and don't worry, I'm gonna share my screen in a second. Let's share application, our studio. So I want you all of you to open up our studio. As you can see, you probably don't have the 4 windows open. You probably have 3, and not necessarily in that order. So let me go. First of all, let's close most of these things. Oh, this is a spoiler. You could use this. What is this? Um, yeah, this is old. This is what we're gonna see. And something else. Isn't this the same? No. Sure. Let's save it somewhere. Okay. So, first of all, why is my art studio black, bluish, and yours is white? Oh, Yampiro wants mine to be white. Okay, sure, sure. Just for the class. So I go to Tools, Global Options, Appearance, and then go into another one of these. So, sorry guys, I don't have coronavirus though. I go to Chrome, and then I burn you guys' eyes. Let me increase the font a little bit so you can see better. 14. So, you probably have the window that's called console over here on the bottom left or on the whole panel. This one is, I think, on this side as well at the start. And over here, you do have this one. That's environment, history, and connections. Now, can you guys read properly my screen? Also, I haven't asked this. Can you guys understand me? Okay, great. So, before taking before talking more about our studio, I'm gonna take attendance or else I'll forget. So, Alvaro, just say present or I'm here or I'm not making breakfast or something like that. Okay, great. Alvaro present. Sebastián Aguilar. Awesome. Mauricio Barrios. No, I want you guys to write on the chat box. Yelena. There's no Yelena. Estuardo Chalán. Sebastián Collantes. Jean-Pierre Espinosa. Okay. Xiomi García. Alexander Pacaya. Roy Portilla. Fernando Ruiz. No, Fernando Ruiz. Sebastián Salinas. No, Sebastián. Giuseppe Valeriani. No, Giuseppe. Andrés Vilcabomán. And Marcelo Villar. Awesome. Let's go back to our. So, how do you guys open a window just like this? So you go into File, New File, you open up an R script, or you learn the shortcut, which is Control Shift and N. So if I write Control Shift and N, a window will pop up. I can write anything I want here, like students. This is an R script. The thing is, if I wanted to run this, now how do you run stuff in R? How do you run any line or any script? If you look over here, there's a button that says run. This one will run just the line. You can click this, or you can use the shortcut, which is much more useful. That's Control but plus Enter. Now, if you try to run something like this, you'll error out because hello students reading like this expects an object called hello and an object called students. Now, if I wanted to have text, I would need to wrap this up into quotes. If I do this, now there's no more error. I'm just running a variable that's pure text. Okay, so back to the other script. Oh, so Jesus messaged. I'm gonna take a picture with you guys. There you go. You haven't met Jesus yet, right? I believe your first class is on Friday. Yeah, okay. Back to our. Okay, let's go back to our. So these things with hashtag before them, there are comments. Okay, in most programming languages, you can create comments in order to have a more ordered workflow. So if I write something really simple, like 3 plus 4, and I run it, what do you expect it to be? Yeah, 7. So you can see on the right that I get an output of 7. So I can do easy mathematical operations, right? I don't have to put in a space in between them. I can just do this. The more it's more ordered, to have an space. You don't need it. Again, 5 of flat, and 5 minus 5, 0. 3 times 5, 15. Obviously, parentheses work, so 5 plus 5 is 10, divided by 2, 5, exponential. 2 to the power of 5, 32. Do you move your console to the upper right side? And how do I just run that line? I put Control and Enter. If I'm positioned on a line and I don't have anything selected, it'll run the whole line. If I have a selection, it will just run that selection. And onto Mauricio's question, I go into Tools, Global Options, Pane Layout, and I decide what goes where. All right, let's continue. So modulo operator. Most of you probably don't know this one. So modulo is like the residual value. Okay. Say if I do 2 modulo 2, what's actually doing underneath is 2 divided by 2. And then what's the residual to make it a whole division? So for example, 5 divided by 2 is 2.5. So 5 divided by 2 is 2 times 2 and half times 2. Now, half times 2 is 1. So if I do 5 modulo 2, I will get 1. It's really useful when you want to know if a number is a divisor of another one, or how far are you forced from a certain value or a certain time period. Okay, I think it's pretty straightforward, right? So let's go into a little more interesting stuff. How do I assign a variable? So you can do, I'm gonna put out a disclaimer here. You can do this. You can do x is equal to 42. Now you can do this. I don't like it. Why I don't like it? It's a technical and a little bit more advanced reason, but I think the equal should only be used in functions, and we're gonna see that later. I don't know if we're gonna reach that part this class, but for me at least, the equal sign only in functions. Now this one is the sign operator. How do you write this out? It's two ways. So you can either type it, so this one and a dash, or you can do alt dash. So again, it's alt plus dash. And if I run this, you can see that on my environment, it's probably over here for you, but in my environment, I have a value that's called x, that it's a numeric and it's occupying 55, 56 bytes of my memory, and the value is 42. Now, anytime that I want the number 42 now, I don't have to write 42. I can write x. So if I just run x, then I get 42. Now, for those who took apply statistics with Ale, and you remember her variables that were called like animal names and stuff, you're not gonna miss those. I'm gonna use those kind of variables as well. Yeah, just like that, mariposa, caracol. Exactly. So apples. Let's make a variable. A variable doesn't have to be just one letter. It can be anything as long as it's connected. So my apples is 5. By my apples, I'll get 5. Let's make my oranges. And let's do my apples plus my oranges. Since those two are numeric, this one is 5, this one is 6, I'll get 11. Now I can save that in a variable. So if I look at my fruit over here, it says it's 11. What else? Let's go over here. Let's talk about types of variables. We've already seen numerics. There's also characters. Characters are basically text. And it goes with quotes or with this types of quotes. Remove this ones, the apostrophe like. Any of them work when you're doing text mining. You're gonna have to use both, but they do the same. So let's save this, and then there's logical variables. So those three are the types of variables. So you have numeric, character, and logicals. Logicals are true or false. You do have to write them on all caps, just like the false is like this, true is like that. You can do T or F. I don't like it because you can mess up a variable that you have onto another place. So you have numerics, characters, and logicals. Let's learn how to use them. Let's introduce a function called class. If you run class of a numeric variable, you'll get that it's a numeric. If you run it on a character, you'll get character. If you run it on a logical, you'll get logical. By the way, if you don't understand something, stop me and I will explain it to you. Otherwise, I'll keep going. I guess I'm gonna keep going. All right. So with Vegas stuff, I'm gonna do a numeric vector. I'm gonna do a character vector. I'm gonna do a Boolean vector. Now, what's a vector? So you guys have taken Maths 3, you've taken Maths 1. You know what's a vector in theory. So a vector is a two-dimensional object that's either like this or like this. By default, on R, vectors are like this, so horizontal vectors. And on the environment window, you can see it's one row, 3 columns, one row, 3 columns, one row, three columns. And you can see what's inside. So, for example, Boolean vector is true, false, true. And it's going to allocate in the memory as true, false, true, like with the two other ones. In order to create vectors, you need this operator, which is called C, but it's a function actually. You need this function, which is called C, and it stands for concatenate. Okay. Let's do some examples. Let's say you go to Vegas and you play two things. You play poker and you play the roulette, and you go the whole week because you don't want to mess up a Vegas trip, right? And this is your winnings on poker each day of the week. Likewise, for roulette. Now, just on eyesight, you can see that you messed up on Thursday, right? Let's check a little function that's called names. Okay? What names does is it outputs the names of any object. Say, if I do names, you can also write on the console window and just to test stuff out, right? Write your names of, say, my apples, I get null. That's because my apples doesn't have any name right now. If I do names of poker vector, I get null as well because I have not assigned any names to poker vector. Now, how do I assign names to poker vector? I do names of poker vector that's currently null, as you guys can see. I assign it just like creating a variable, another vector that's full of characters. So once I do this, and I want to check out poker vector, I get a neat table like this, but it's still a numerical vector. However, you can see roulette vector is a numerical, one row, three columns, and just numbers. Poker vector is a named numerical, one row, five columns. So it's a little bit different. However, on the inside, it's still a numerical. If I write that function we saw before, that's class, poker vector, it's still a numeric. Can I call Monday? Oh, I can. So we're gonna see subsetting and filtering a little bit below, but I'm gonna do a little bit of a spoiler. If I do poker vector and I do Monday, I get the Monday. That's a little bit of a spoiler. Do the same for the roulette. And when you're programming, it's like a dictionary, yeah. It will be like it'll be the equivalent of a dictionary on Python. However, dictionaries have a little bit neat feature that's the lambda settings, and R doesn't have that on vectors. Or it does have a lot better stuff, I would say, that we're gonna see when introducing packages. So when you're programming, you don't want to repeat yourself. So I have this twice. and it's the same, right? So I could have just used a variable. So I'm going to reset poker vector and roulette vector. We are back to just numericals. If I write it over here, there's no more names. If I create a character vector, that's my days of the week, and I do the same, except right now I'm not repeating myself on this whole thing. I know you can just do Control C, Control V, but it's more ordered this way, right? If I do this, I get the same output. Let's look at the roulette. I get the same. So let's do a little bit on before going back into the Vegas example. Let's go and do operations with vectors. I'm gonna create two vectors, A and B. I'm gonna sum them. Now, what do you guys expect the output to be? So I have 1, 2, 3, and 4, 5, 6, and I'm doing A plus B. 5, 7, 9. 5, 7, 9. Okay. And the answer is, oh yeah, it's 5, 7, 9. Don't worry. It's nothing out of the ordinary. Yeah, when you're summing vectors, you just take the same position in each one. You sum them. 1 plus 4, 2 plus 5, 3 plus 6. Now, what happens? And I don't know if I have this later on. I don't remember. What happens if you have this? And I do. What do you guys expect that to be? No, it's not the Batman theme song. 2, 2, 3. Yeah. So R, because not all programming languages do this. Okay. R understands anything that's higher than 0 as true, and false is basically 0. 0. So if I do this, 2, 2, 3. Okay. If I do a multiplication, I get 1 times 1 is 1, 0 times 2 is 0, 0 times 3 is 0. Okay. That's just a little bit of a deviation. Let's go back to Vegas. So I assign my names, and I want to know how much I made each single day. Now remember, poker vector and roulette vector are named. Now, because they have the same names, I can use a simple operation like summing. So if I run total daily now, I'll get the sum of each of the days. Now you can see you're really messed up on Thursday. Lady Luck wasn't on your side, but you did decently on poker. on Friday. Now, if I want to know how much I made the whole week in poker, you can use the function sum. Now, sum takes 1 plus 2 plus 3 and gives you the output. Now, if I do the sum of poker vector, total poker will be 140 minus 50 plus 20 minus 120 plus 240, and that's 230. If I do the same with roulette, you can see you lost 314. Now, if you want to know how you did on your whole trip to Vegas, you lost $84. Now you can say that, wow, 84 isn't that much, and you had fun, you were in Vegas, but that 84 could be easily 84 million, right? Okay, so let's go into comparisons. So I want to know for a fact, because I don't know if 230 is more than minus 314. I want to know for a fact if the winnings I had on poker were greater than the winnings I had on roulette. It's true. 230 is greater than 340 minus 314. So you get true. Okay, whenever you do any comparisons like this, you'll either get true or false, or maybe if it doesn't apply, you're getting an A. The other types of logical operators are equals with two equals. So 2 is equal to 1 plus 1. And I didn't write out 1 plus 1. I wrote out 1 plus 2, so it's false. If I write actually 1 plus 1, you're going to get 2. Now, the other one is the not operator. So the not operator is written as an exclamation sign. So not true is false. Not false is true. So not 1, 2 equals 1. This should give me false. With the not operator, it should give me true. There's also the and operator. So withhold this equation, I get true. And if I do true in something that's false, say 3 greater than 10, I'm going to get false. If I do 3 is not greater, it's less than 10, I'm going to get true because this is a true statement. This is a false statement that I'm nullifying with a not. So all of this is true, and all of this is true. I'm going to get true. Go back to Vegas. So remember, I promise you guys, we're gonna learn how to subset. Poker vector, again, it's this thing. Monday, Tuesday, Wednesday, Thursday, and all your winnings on poker. If I do this type of brackets and the number 3 inside, I'm gonna get the third element on my vector. Now, for example, Jean-Pierre has, it looks at least, that has experience with Python. On Python, you start numbering at 0. On R, you start numbering at 1. So Monday On Python would be 0. On R, it's 1. So this is the first position. Second, third, fourth, fifth. If I take out the third position, I get Wednesday. And like I showed you guys before, you can also do, you can also write out Wednesday. There you go. You can also write out Wednesday. Now you can see that if you don't write in something that's findable inside the vector, you do get an A. Yes, any kind of names and variables in R is case sensitive. So A is not the same as A. You get false with that. Okay, let's go back to subsetting. So just like you can do a single number, you can put a vector over here. So if I do poker vector and I subset for the second, third, and fourth position, I'm gonna get Tuesday, Wednesday, and Thursday. Tuesday, Wednesday, and Thursday. Now, if all the numbers are contiguous, that means that they go um, right next to the other one. I can do these 2 points, and these points allow me to create a vector of contiguous numbers. Say, I do 1, double 2 points, 2 points, 4. I get 1, 2, 3, 4. I can do the other way around. If I 5 all the way to 1, 5, 4, 3, 2, 1. So if I do the same on the roulette for 2 all the way to 5, I'm gonna get all days except for Monday. There's no Monday over here. If I just wanted to avoid Monday, I could have also used a minus. So if I do -1, I'm gonna get everything except the first position. So we'll have the same output. Now, just like we did before, you can use, when it's a named vector, you can use the names in order to subset. So this will give me Monday, Tuesday, or Wednesday. Now, so far, any questions? No? Looks like we're good. So some more operations and functions. If you want to know on the first 3 days poker winnings, so poker start, what was the average winning per day? You can use the function mean. Mean calculates the average. That's your average winnings. If you want to answer the question, which days did you make money on poker? Now remember, poker has this. I do not have to use this 1 through 5 because I have 1 through 5 elements, but it's just to remind you guys that you can use the 2 points. So 2 all the way to 5, So poker vector to 1 all the way to 5. It's going to give me the whole vector. And greater than 0, this is going to evaluate each day if it's greater than 0. So I'm not going to get a single true or false. I'm going to get a vector of logicals. I did make money on Monday, didn't on Tuesday, did on Wednesday, didn't on Thursday, and did on Friday. Now this is the same, right? Now remember, I told you guys that you could subset with logicals as well. So I have my selection vector that's true, false, true, false, true. So if I apply this and I do poker vector subsetted by selection vector, then what do you guys think I'm gonna get? The days. No, not the days. There will be days over there, yes. It's not actually the days. The values, yes. Which values? Only the ones where I did make money, yes. So if I run this line, I'm only gonna get Monday, Wednesday, and Friday because those are the days that I did make money. Now, in order to answer, um, Sebastian, how do I get the names? If I wanted the names, I could have done names, poker vector, and then I'm gonna get Monday, Wednesday, and Friday. I'm gonna leave that over there as an example. So I can do the same for the roulette, right? The roulette, I only made money on Wednesday and Friday. So when I when I get my winning days, I'm gonna get Wednesday and Friday. Okay, that's vectors for now. So we've seen individual values and variables that were numerics, characters, in logicals. We've seen vectors that have either numerics, logicals, or characters. And now we'll see matrices. So you've already seen matrices as well. Matrices are a two-dimensional object that have either numerics, logicals, or characters. So how do I make a matrix? In order to make a vector, I need it the concatenated function. In order to make a matrix, it's more straightforward. I need the matrix function. Now, there are three ways of making a matrix. Well, more, but these are the most standard. So you give it data. Now, 1 through 9 is a vector that's 1, 2, 3, all the way up to 9. N row says that I want 3 rows in my matrix. So it's gonna divide the number of elements that I have. So I have 9 elements divided by 3. That means we're gonna get 3 rows and 3 columns because I'm telling them I want 3 rows. By row is just an argument that tells R to understand that I want my data divided by 3. I get a matrix. First three elements on the first row, the second three on the next, etc. Okay. So by row, over here, tool R to position my numbers going like this. The first number, the second one, the third one, fourth one, etc. If I had it on by columns, it would have been 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I could have, by the way, this is the default thing. You don't even have to put the argument over there. I'm just putting it as an example. If you just wanted to do I want three columns, I will understand it. However, it would have done by columns by default and not by rows. So if I do this, and I tell exactly the dimensions I want my matrix to have, then I get the same output as the one before. So one function that you're going to use a lot with matrices is the function dim, which is dimensions. My dimensions are 3 by 3. Let's do a Star Wars example. So analyzing the box office numbers of the first two trilogies, so not including the latest one over here, we're going to see the original trilogy first. So these are numbers for the box office results on onshore, offshore, and US. If I have all my movies, I can create a vector. So box office is gonna look like a mess, right? But once I create a matrix and I tell them that I want 3 rows because I have 3 movies, I want it by rows, so these two first, then these two, then these two, etc. And I get this. This is my first movie, A New Hope, Fire Strikes Back, and Return of the Jedi, right? I could have done the construction of the matrix just by doing this and not assigning it to a variable that's called box office. However, this way is a lot more ordered. Okay. If anyone looks at this, they don't know what's going on. So let's give it names. I'm gonna create a vector with the regions, and I'm gonna create a vector with the titles. So for matrices, you don't just use names because you have 2 dimensions, right? You have the columns, you have the rows, and both can have names. So in order to name the columns, I use col names. In order to name the rows, I use row names. By assigning these 2 vectors to the names, I get something that's actually understandable. So these are the box office numbers for New Hope on the US and outside the US. Likewise for the other 2 movies. How can I know how much each movie made on the world? I can use the function row sums. Now row sums will go in each row and sum the elements. So for A New Hope, it'll sum US plus non-US on a Empire Strikes Back, it will sum 290 plus 247, etc. So I get a vector, because remember, once you have, so a vector in and of itself is a matrix with one of the dimensions being 1, right? So if I just have one dimension left, it'll turn into a vector. If I do class worldwide vector, it'll turn me into numeric. Okay, so I was over here. So worldwide vector, and I get the winnings summing US and non-US. Now, this is probably really useful for something, so I can add it right next to non-US. How I do that? I use a function called cbind. So cbind, it's small for column bind. So I'm binding to my matrix a new column. So first I give it my matrix, and then I'm gonna give it a vector. So now I have US, non-US, and the sum of both of them. Okay. Now I'm in order to not do the the whole procedure as again with your trilogy, I'm gonna just load it out here. So this is the prequels, right? So Phantom Menace, Attack of the Clones, and Revenge of the Sith. Maybe I want to have both of them, right? So R bind, just like C bind, instead of being column bind, it's, what do you think it is? Ew, no. Yeah, row. So row bind. I'm gonna get all my movies on the same matrix because they have the same names and they have the same number of columns. I can use row bind. Okay. Now, how do I get the sum for each region? Now, before we wanted the sum for each movie. Now I want the sum of each region. Okay. Just like row sums, there is col sums. So this one sums the whole column. So in the US, they made 2000. Outside the US, 2080. Now, just like vectors, I can subset on a matrix. The difference is vectors had just one dimension. So I just needed to use one number. On matrices, they have two dimensions. So you have to specify what you want for the rows and what you want for the columns. Okay? If you give it nothing, then R assumes that you want the whole spectrum of rows. Or if I give it nothing over here, I want the whole spectrum of columns. So if I give it nothing, comma 2, then I'm gonna get all rows, but just the second column. And of course, now I only have one dimension, right? So it turns into a vector. If I wanted to know how, on average, how much Star Wars movie made offshore, so outside the US, B47. These are in millions, by the way. Um, if I wanted to subset the first two rows, so the first two movies, and offshore, so outside the US, I'm gonna get A New Hope and Empire Strikes Back, the first two movies of the saga. If I wanted to know what's the average on those, I get less than the average of all of them because, people, there were less people on the past. There's inflation. There's um, there's more access to cinema, etc. Now, how can I know approximately how much, how many people went to see these movies? So on average, a ticket is $5 on average. Okay, so if I divide all the box office's numbers by five, I'm gonna get the average of visitors. So on average, the one that had the most visitors was the Phantom Menace outside the US with 110 million visitors. Okay. Now, this is not exact estimation, but what's important over here is that you just divided a matrix by a number. Okay. Just like in math, this would be a matrix times a scalar, or in this case, divided by a scalar. Okay? Now, those were matrices. Let's talk about factors, and this one might be new for you. So, factors, if you remember, what was it? On EViews, um, they are like masked values. So, a value that might look like a character, but is actually a number underneath, or or a character there's another character underneath. Okay, so for example, or the other way around, a character that's a number that's a character underneath. So we're gonna have a gender vector. Okay, so this vector is just some characters of male and female, and we're going to transform that into a factor. Okay, in order to transform a character vector into a factor, we just use the function factor. Very straightforward. Now you see, when I printed my character vector, I got the single elements with quotes next to them. If I print out a factor, I don't have quotes, but I have this thing called levels. And what does this mean? So levels are the unique values that my character vector used to have. Now, R will no longer understand that this is a character. For R, this is a number 2. This is a number 1. Why? Because this is the first level and this is the second level. However, you're gonna see male, female, female, male, male. Okay? So some examples. I'm gonna have an animal vector, some animals. I'm gonna turn them into a factor. Now, I used to have repeating values on the other one. Now I only have unique values. But still, I'm gonna have this. Now, take into account something. The levels are ordered just like um, the alphabetical order of my values, of my character values. Okay, so the D goes before everything else. So donkey, elephant, giraffe, horse. Okay. There's something else you can do with factors. You can do comparison with factors. So I'm gonna get a temperature levels vector that's basically high, low, high, medium. Now factor, the function factor, has more arguments. Now, how can I know what does a function do? So I use the question mark sign, and I type out the function, and I'll get the help page. So factor has the first argument as the data I want to give it. The second argument is levels. The third argument is the labels that for default are the levels, but you can change them. Exclude is if you want to take out any value and put it, for example, as other. Ordered, we're going to see that now, is if you want them to be in a particular order. Okay. Now you can write order or ordered. It's the same thing. So if we go back to this, what do I have? If we go back to this, we give it our data. We say we want an order, so there's a difference. So before, there was no hierarchy in between the elephant, the giraffe, the donkey, and the horse. However, high is better than low, and medium is in between. So I want R to notice that. So I want an ordered vector, an ordered factor, I mean, and I give it the levels in the order I want. So I want low to be the lowest and high to be the highest. So before I run this, check out the line of levels for the animals. And now, if I run this, I'm gonna get the levels with is greater than or is less than. So low is less than medium, and high is less greater than medium. Okay. So if I do factor temperature vector, one that's high is high, two, okay, two is low. If I do is the second element greater than the first one, I'm gonna get false because of the second element was low. The third element, the first element is high. If I do the reverse, then because I know that high is better than low, and I've told R to interpret it that way, I'm gonna get true. Now, what if I try out, say, with the animals? So factor animals vector. I'm gonna try out with the elephant and the giraffe. So is the giraffe greater than the elephant? I'm gonna get an NA and I'm gonna get a warning telling me that R doesn't understand comparisons between these factors. To R, these are not ordered. Okay. So let's say we had a survey, and on the survey we had the data of this gender of the person as M, F, F, M, M, as to male, female, male, female. Yes, 1 and 3 are the same, high. So if I do I'm gonna get true. So if I have a where's medium? Medium was number 4. No, number 5. So if I do 3 is equal to 5, I'm gonna get false because 5 medium. Okay, if you have a survey and you get the data as MFFMM and you factor that out, you're gonna have levels as F and M. But if you, just like you had names, the factors have levels, right? So if you replace those levels and instead of F and M, you write out female and male, your whole data now appears as male, female, male, male. Okay. Now the cool things on factors is that you can create a summary for them. So summary is a function that works not only on factors, but in on most R objects, and it gives you useful data that you could need. So factor of a vector, the summary of a vector will just give you the class. The mode is basically the class, but how the underlying data is saved. Length, it has 5 elements. If you do summary on a factor, is there an earthquake? I think there's an earthquake, guys. Be right back. Are you guys feeling that? Yeah. No? Okay. Yeah, F in the chat. I think it ended. I'm on Zamborja as well. I felt that. Oh yeah, I just got a message from somebody in La Molina. So there was an earthquake. Yeah, it's up. No, San Borja is not earthquake free. I'm on San Borja as well. Okay, go back. Check your facts. Okay, so we had the summary of a vector, and it gave us, this is useful, yes, but we could have seen that just by looking into our environment. Let's clean our environment a little bit because we have a lot of stuff over here. But for cleaning up your environment, you use the broom over here. So I'm gonna run this again. So if you run your summary for a factor, you get more useful stuff. You get how many of each individual level there is in your factor. I mean, if you have 5 points of data, it's not that useful. If you have like 1,000 or 1,000,000, and you don't have 2 factors, you have say 7, it's more useful. Um, yeah, just like I told you before, you can subset factors as well. And do you notice that when you subset factors, even if you just have male over here, R still keeps that the levels are female and male. So this is something fun to do when there's a division on female and male in the class. However, I think we have no female student today. Um, there's I know we have Xiaomi. Okay, Xiaomi. They pay their license. Xiaomi. What do you think we're gonna get over here? So probably Xiaomi went to sleep. All right, gonna pick someone else then. Um, Alvaro, what do you think we're gonna get? Why do you think it's true? No. So recall two lines before. So male is a subset, and female is another subset. So each one is just one element. Now the thing is that female is the first element, so underlying is the number one, and male underlying, since it's the second level, is the number two. However, I didn't give when creating the factor, I didn't say it was ordered. Okay. So when you try to do comparisons with non-ordered, oh, wait, when you try to do comparisons with non-ordered factors, I will not know what to do. But going back into the high, medium, low example, if you do it with velocities, you order it such as R understands that slow is less than fast and less than insane. And when you do comparisons, so DA2 is slow, DA5 is insane. So if I want to know if a slow is greater than insane, I'm going to find that that is false. So these were basically the most basic art object types and types of underlying values. Now we're gonna see data frames. I'm gonna deal with my environment a little bit. So data frames. There are some data frames that are already saved in R. So for example, I have my environment that's empty right now. Yeah, I'm gonna share the code with that. The main purpose for levels function is just as names on any vector or on any matrices. So the usual applications of a factor is mainly, at least in my experience, for doing plots and graphics. So if you wanna if you have data on we're gonna look at it right now actually. If you have a data frame, which is kind of so a data frame is kind of like a matrix. However, the difference is that on a matrix, you can only have the same type of data in each column. On a data frame, you can have different types of variables. Say, for example, you create a data frame with a function data frame. And you can have, we're going to see this later, but you can have first column named A, and I can have 1, 2, 3. I actually don't even need C. Then you can have something called letters and have the first 3 elements and call that B if you want. So I have numbers and I have characters on the same object. And when you add factors to this, there's some other letters, or it's not this one. I need to give it a name. No, you don't want to call it C. Facts. Okay, so I have 3 types of stuff right now over here. If I save it as that, so before, when you had a value, you didn't have this arrow on the left. I'm gonna get to head. Wait, hold on a little bit. I didn't have this arrow over here. Now, if I click the arrow, I can check just like what I had on values of each variable on my data frame. What is it? Now, if you see, B was recoded into a factor, and it was a character. So if I just run letters 1, 2, 3, you can see that it's a character. It's not a factor. The thing is, when you create a data frame interprets by default everything that's text as factor. If you don't want that, you can use the argument strings as factors. You write out false, it's back into a character. Okay, so let's go back to our cars. So cars is a data frame with different cars and different statistics. So miles per gallon, how many cylinders, how many, what's the horsepower, wattage, etc. So head allows you to explore a data frame faster. So head, what I did just by running this, I'm getting the whole data frame. That could be messy, okay? If you do head, you get the first 6 elements by default. If you do head, comma, 2, you get the first 2 elements. 10, you get the first 10. By default, 6. Now, the equivalent on the other side of head is the function tail. With tail, I'm going to get not the first 6 elements, I'm going to get the last 6 elements. Now, next is str. str means a structure. So I'm going to investigate the structure of this data frame. This data frame, and if I save it, over here, I'm going to get something very similar. Okay. So empty cars is full of numerical variables. I have 32 observations per each variable, and I have 11 variables. Again, all of them numeric. And why are these dollar signs appearing? Because if you do empty cars, dollar sign, you can enter inside the object and get any one of its vectors. Okay, let's say the miles per gallon, and I get the vector that's underlying inside of it. Let's do a last example. Maybe we can do two. Okay, so I have a names vector with the planets, and I'm gonna get the types of planets. Their diameter, their velocity of rotation, and if they have a ring or not. Then I'm gonna create a data frame with this. Remember, to create a data frame, you need the function data frame. I'm gonna assign all my vectors into my data frame. And I'm gonna input strings as factors as false because I want my characters to be characters. And this is my data frame. Okay, I have different stuff. I have characters, and I have numerics. I have logicals. Okay, if I check out the structure of it, I get that I have 8 observations. That means 8 rows, 5 variables, so 5 columns, and these are my variables: characters, numerical, logical. Say I can investigate any planet I want. If I want the diameter of Mercury, I know that Mercury is the first row and the diameter is the third column. So that's that diameter of Mercury. If I want all the data on Mars, I just get the fourth row. So just like a matrix, you have 2 dimensions. And you have to wrangle in between that. Now, since all my variables are named, I can use the name as well. So the first 5 values on the diameter. For example, I can select just one of the columns. Let's say the column that's called rings. Remember, rings was logical. So if I subset something by a logical, I'm gonna get only the ones that holds true. So if I get only the rows that say true, I'm gonna get the last 4 rows of my data frame. Only the ones that have rings equals to true. Okay. Just like using the brackets, I can use the function subset. So subset takes a data frame as the first, well, an object as the first argument, and then the condition. So my condition is that the diameter should be less than 1. I'm gonna get all the planets in which the diameter is less than 1. I can do the same not using subset and using the brackets. I can create a vector with a diameter. I can create a vector with diameter less than 1. I can put it subsetting by the rows. I want every single column, and I'm gonna get the same result. So before going into something else, let's understand the function order. So if I have a vector that's 100, 10, and 1,000, if I wanted to order that, say from the lesser value to the greatest value, the correct order will be on. Oh. The correct order will be 10, 100, and 1,000, right? So that's exactly what the function order does. Order of A will tell me that the first one that should go is the element number 2. The second one should be the element number 1, and the last one is correct in that order. So if I do subset of that, subset doesn't have to be less stuff than usual. It can be the same stuff, but in a different order. So if I do A brackets in this vector, I'm gonna get 10, 100, 1,000. Another way around is to use the function sort. That basically does this. So if I order my planets, so before my planets look like this. If I wanted to order it by the diameter, then I can create a vector that's the positions, and I can use a subset inside the brackets to order it by the positions. So now I have my planets ordered by the smallest diameter to the largest one. So that's data frame. Before ending the class, we're going to see list. So lists are the most broad object in R. So lists are basically, you can put anything in any order you want, in any shape or form you want. So in data frames, we could have different types of variables inside of it. However, they all need to be of the same length. What does that mean? That they all need to have the same number of rows. Okay? Unless you don't care about that. So we can have a vector of 10 numbers, a matrix of 3 by 3, a data frame, and you can construct a list with the function list. And you can have all of that inside an object. So this is our vector, this is our matrix, and this is our data frame. And look that it's subsetted by these double bracketed numbers. We don't want to have those double bracketed numbers. We want names, right? We want to know what's inside. So just like data frames, you can use a name and equal your data, and it will interpret that as the names. Okay. So again, this dollar sign appears. So if you do my list, you do dollar sign vec, dollar sign math, etc. You're gonna get your underlying objects. Again, let's roll with the movies. So let's do an example with The Shining. So the name of the movie, The Shining, the cast, revenues will be a data frame. Don't disregard the how I'm making the data frame, but it's just a data frame. And I'm making a list. Movie name, actors, reviews. So my list right now is the movie name, the cast, the scores, and comments. And this is one whole data frame. Okay. So if I want the actors, I just use the dollar sign. If I want the second actor, I can subset an already subsetted thing. If we forgot something, we can use the function concatenate, just like vectors, and add it back. So if I want the year, the movie, and I look at the movie, here's here's here. And just to finish up, I can look at the structure of a list. Now before, if I looked at a structure of a data frame, it told me how many observations, so how many rows and how many variables I used to have, right? On a list, it tells me the same thing. However, before it tells me how many elements my list has. And you can see that on a character, it tells you a character. On a vector, it tells you the number of elements, ones underneath. On a numerical, it tells you that's numerical. On a data frame, it tells you that the number of objects and the number of variables. Again, inside, it tells you what's inside, etc. Okay. So we went through this a little bit fast. Um, this is the most basic introduction of what's underneath are and how to use the basic operations and the basic objects. Later on, we will see how to use this language and its applications on time series, on the stock market, on simulations, on some studies, analysis, etc. Okay. So yeah, any questions, guys? Okay. Anything that you didn't understand in R? Yeah, I will share the code. Don't worry. Oh yeah. Before, yes, to save this, just click on File and Save, or Control plus S. Before this, since I like the idea of it, and because probably most of the semester will be online, I want you guys to think of class rep and to either have it ready by Friday or maximum the next Wednesday. Why do I put names factor? No. Because names gets the because names gets the names of an object. So poker vector, selection vector, well, basically that's the same, I think. So poker vector, selection vector is subsetting these the selected elements and then getting you the names of those. On the other side, you're getting the names and subsetting the names. So the final result in this case will be the same. Should be, at least. So yeah, I will share the code. Um, I want you guys to select a class rep for maximum our next session. On Friday, you'll have your session with Jesus. You'll see a little bit of review on stats 2, stats 1, and econometrics. I don't know if you'll get to econometrics, but on stats 1 and 2, probably on Saturday, a little bit of econometrics. And then on the next Wednesday, we're going to see a review of stats ourselves. Okay. So yeah, check out check out probabilities, check out integrals. Um, check out. That's mostly it. Yeah. Um, Jesus and I are planning on changing how the usual evaluations on this course happen. Because before, I don't know if you talked to any of your classmates that already took this course, at least last semester, which is when I started teaching, because I changed the way that stuff happened. You had an exam on class, and then you also had a work on by groups for home. We're probably going to maintain that second part and probably going to increase the weighting on it. I don't know if I'm going to keep it happening as a group project. What's gonna be in groups definitely is the final project, which is probably you haven't heard of this or you have. The final project of this course is basically you guys have to develop your own trading algorithm and apply to stock market, and the best group wins, right? Um, yeah, this is a general idea. We're going to increase the the weightings on the participation. So you guys do want to participate as much as you want and as much as you can. Okay. If I don't, we don't have the syllabus finished yet. We're retouching the weightings on the evaluations. Once we have that, we will upload it. Um, what else? What else? So yeah, you guys want to increase your participation. You guys want to review stuff. I'm gonna, as well as this code, I'm gonna be uploading a couple of guides of something called the Tidyverse, which is some packages on R. And if you guys could be more active researching how stuff work, I'm always gonna be at your disposition to answer stuff. I don't really like to use the mail because I usually have the work mail open. You can WhatsApp me. Uh, you can message me on WhatsApp and 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 ask me stuff over there. If you want, you can create a group. I don't mind. And yeah, that's basically it. Any questions before finishing up? Okay, yeah. So as a homework, review some basic stats and econometrics. Review, think of who might be your class rep. Um, start participating more. If I call if I call you in the class and oh you want to be, sure. If people are everyone agree, sure. Um, what else? This is not a democracy. So what else I wanted to say? Yeah, I will be uploading some stuff for you guys to review and Russian stuff. And yeah, have a nice week, guys. I hope you guys are fine in the quarantine. Hopefully, this doesn't extend a lot more than May. The projections are either start of May or end of May right now. However, it might extend more than that. It's not for small caps, but still, it's good for general health. But yeah, have a good week, guys. No dog pics. Okay, get it together and communicate your decision back to me. All right, see you guys. Have a good one.